Let's start with a question that puzzles scientists for a long time. Are atoms truly indivisible, as Dalton once claimed? According to Dalton's atomic theory, atoms were thought to be the smallest, indivisible units of matter. But as scientific experiments progressed, especially those involving electricity and gases, new evidence began to emerge. Scientists began asking, if atoms are indivisible, how do they account for electrical properties observed in matter? This curiosity opened the door to a new understanding of atomic structure. Observing how matter reacts under the influence of electricity revealed a critical insight: atoms are composed of even smaller, charged particles. And that discovery forever changed our understanding of what matter is made of. To understand the presence of charged particles in matter, let's recall a few simple experiments. Have you ever combed your dry hair and seen it attract bits of paper? Or rubbed a glass rod with silk and noticed it attract a balloon? These effects are not magic, they are chemistry in action. When two materials are rubbed together, particles are transferred between them. This transfer creates an imbalance of electric charges. That's how static electricity builds up. And this tells us something crucial. If rubbing can cause objects to gain or lose charge, then atoms, the building blocks of all matter, must contain particles responsible for these charges. These experiments hint that atoms are not the end of the story, they contain smaller constituents that carry electrical charge. The first breakthrough in understanding these charged particles came in 1897 when Thomson discovered the electron. While experimenting with cathode ray tubes, he observed streams of negatively charged particles moving from the cathode to the anode. These rays were deflected by electric and magnetic fields, indicating they were negatively charged. Thomson concluded that these particles, which he called electrons, must exist in all atoms. Each electron, written as E-, carries a charge of -1. Its mass is extremely small, nearly 1 over 1837 the mass of a hydrogen atom, and often considered negligible. The discovery of the electron was proof that atoms are divisible and contain internal structure. And it raised an important question: if atoms contain negatively charged electrons, where does the balancing positive charge come from? That question was answered through the discovery of another subatomic particle, the proton. In 1886, before the electron was discovered, Goldstein observed faint beams moving in the opposite direction of cathode rays in a discharge tube. These rays, called canal rays, led to the discovery of the proton. Each proton, written as P+, carries a positive charge equal in magnitude to that of the electron, +1. But unlike the electron, the mass of a proton is approximately 2,000 times greater. This made it clear that protons must be located deep within the atom. They cannot be knocked off as easily as electrons. This discovery helped scientists understand that atoms must contain both positive and negative particles to remain electrically neutral. By the early 20th century, scientists understood that atoms consist of both electrons and protons. These two subatomic particles balance each other's charges. The negatively charged electrons orbit around the positively charged core, which contains protons. This arrangement explained why atoms are electrically neutral. The number of electrons is always equal to the number of protons. While electrons are light and found in the outer region of the atom, protons are massive and occupy the atom's interior, forming part of the central nucleus. This realization formed the basis for early atomic models that attempted to show how these particles are arranged inside an atom. So, to wrap up, atoms are not indivisible, they are made up of electrons and protons. Thomson's experiments with cathode rays led to the discovery of the electron, a particle with negative charge and negligible mass. Goldstein's observations of canal rays revealed the proton, a particle with positive charge and relatively large mass. Protons reside in the atom's interior, while electrons are found on the outside. Together, these particles ensure that an atom remains electrically neutral. This understanding of charged particles within the atom laid the foundation for all future atomic models and changed how we see matter itself. I hope this session helped you appreciate how deep insights can emerge from even the simplest observations. In the next class, we'll explore J.J. Thomson's atomic model, an early attempt to describe the internal structure of the atom.